In this tutorial, we're going to take a look at factoring a general trinomial, and the form we refer to as ax² plus bx plus c, and this is the method when a isn't 1. If a was 1 and it's just x² plus bx plus c, then there's a shorter method. You just look for two numbers that have the sum of whatever this is and a product of this, and then you write out the binomials with those two numbers, the two factors. So this is when the coefficient isn't a 1, so like a 6x² or a 5x² or whatever your variables might be. And there's more than one way to do this, but I'm going to show probably the most common method for this. And I have another video called the Australian method, which is similar but a little bit different. So the idea is this: we're looking for two numbers, and if you remember factoring x² plus bx plus c, the sum was this, and the sum is still 11. Okay, so we're looking for two numbers that add to 11, but that multiply not to just the 4, but the product of the 6 and 4. 6 times 4 is 24, so we're looking for two numbers that add to 11 and have a product of 24. And if you did add to 11 and multiply to 4, and I'll point this out in this one, if you ignore the 6 and you were actually there are no numbers that add to 11 and multiply to 4, but if there were, then you would actually just be factoring this if you could find those numbers. Okay, but that's not what you're asked to do, because there's supposed to be a 6 right there. So the numbers that do that would be 3 and 8. 3 and 8 add to 11, and they also multiply to 24. And I mentioned this in the x² plus bx plus c video. There are other pairs of numbers that multiply to 24 besides 3 and 8, such as, well, like the 6 and 4 that we multiplied up here. But 6 and 4 don't add to 11. Okay, there's another pair, 2 and 12. They multiply to 24, but they add to 14, not 11. Okay, so 3 and 8 is the only pair that multiplies to 24 that also adds to the 11. So that's why we're using the 3 and 8. So what we're going to do is we're going to rewrite the trinomial, and we're going to leave the first term alone and the last term the same. But we're going to break that 11x term down into 3x and 8x. That's what we're using the 3 and 8 for. So see, 3x plus 8x adds to 11x, so this is an equivalent form to this. And the reason I want to do that is because now I have 4 terms, and I can do some factoring by grouping. And factoring by grouping works like this. I'm going to common factor the first 2 terms and the last 2 terms. So the first 2 terms, 6 and 3, a 3 goes into both of those, and they have an x² here and an x here, so you can factor an x out of those as well. Now we're only factoring that out of the first 2 terms. So we're going to factor a 3x out. So 3x out of these 2 terms. 3x goes into 6x², leaving 2x, and 3x divided by 3x is 1. The last 2 terms, 8x and 4, there's a common factor of 4 there. So I can factor a 4 out. So if 4 comes out, 8x divided by 4 is 2x, and 4 divided by 4 is 1. Notice what's in here and here are the same. Okay, and under factoring by grouping, if you chose the wrong 2 numbers, like if you use 4 and 6 or 2 and 12, for example, then these wouldn't end up being the same. Okay, so you want them to be the same. So we're now going to common factor, and it's a trinomial. You can common factor a trinomial. It can be bigger than a monomial. We can common factor a 2x plus 1 out. And so what you're actually doing when you factor that 2x plus 1 out is to get the other factor. Factoring it out means you're dividing that 2x plus 1 out of both parts. So when I divide the 2x plus 1 out, this is what happens. See, that divides out here, leaving just a 3x. That's why there's a 3x there. And this divides out, leaving the plus 4. So that's where the 3x plus 4 factor comes from. So those are the factors of this. Now, a name that's used for this method, it's often called decomposition. And the word, because that comes from the word decompose. Decompose means to break down. See, I broke the 11x down into 3x and 8x. So that's why it's called decomposition. So to factor ax² plus bx plus c, we look for 2 numbers that add to the b from the bx and have a product of a times c. And so you use those two numbers to break that bx term into like two different terms, and then factor by grouping. So we're going to take a look at some more examples, one here and three on the next page. So 5x² plus 7x minus 6, we're going to factor that. So we'd be looking for two numbers to add to 7 and multiply to the product of 5 and negative 6, which is negative 30. And the numbers that do that, think of the pairs of numbers that you can think of that multiply to negative 30. And the only pair that do that are 10 and negative 3. 10 and negative 3 add to 7, and they multiply to negative 30. So that's my decomposing numbers. So we rewrite the trinomial with the first and last terms the same, and we decompose that 7x term into, and this is what we use the 10 and negative 3 for, into 10x minus 3x. And it doesn't matter which you write first. Just like up here, I could have put the 8x first and the 3x second. I could put the negative 3x first and the 10x second. Some people think, well, I should put the 10 first because there's a common factor of 5 here. It works out the same anyway. It does not matter. So we're going to leave it like this. So 5 goes into both those, and they have x's as well. So you can factor a 5x out of these two terms. So 5x² divided by 5x is x, and then 10x divided by 5x is 2. Now in these two terms, if that's a negative, see it wasn't up here, I had a positive 8 for the 8x. If that's a negative, then always factor a negative out. Okay, we don't want to have a plus here. So I can factor a negative 3 out of those two terms. So negative 3 comes out of negative 3x, leaving an x. See, if I factored just a 3 out, then I would have, I'd end up with a negative 3 here. So I want it to be the same, of course, as this one. So negative 3 comes out, negative 6 divided by negative 3 is positive 2. Again, these are the same. That's exactly what we want. So we common factor an x plus 2 out, and what's left is the 5x minus 3. And so that's how the 5x² plus 7x minus 6 will factor. So here's the examples on the second page. You might wonder why that bottom one is so short, but we'll get to that. So 2x² plus 7x plus 6, we're looking for two numbers that add to 7, multiply to the product of 2 and 6, or 12, and that would be 3 and 4. So we rewrite our trinomial with the 7x changed into 3x plus 4x. And there's a very small common factor in this case. In the first two terms, it's just x, because there are no common number factors of 2 and 3. So we can factor an x out of these, so that's going to be a 2x and plus 3. And we can factor a 2 out of these. So 2 comes out, 4x divided by 2 is 2x, 6 divided by 2 is 3. Again, what's in here and here are the same. And so we factor the 2x plus 3 out, and what's left for the other factor is x plus 2 here. So that's how that trinomial will factor. Now, I haven't mentioned this in the first three examples, but always look for common factoring. And first, before you get into any trinomial factoring, decomposition or otherwise. So notice in this trinomial, all these numbers are divisible by 2. If you didn't do that, you'd be looking for two numbers that, now the number is going to be big enough as it is, that add to 34, so that's fairly large, but multiplied at negative 240. Okay, 8 times negative 30 is negative 240. And you might start thinking, well, geez, negative 240 is pretty big. There's going to be a lot of numbers, pairs of numbers that multiply at negative 240. But if you make that common factored first, if you factor it out first, then that sum of product numbers get a lot smaller. So we'll factor a 2 out. So again, each of these is going to be divided by 2, so 4m squared, 17m, and then negative 15. So now the sum is only 17. And the product is only 4 times negative 15 is negative 60. So it went from negative 240 to negative 60. Okay, so quite a bit smaller, actually by a factor of 4. So the numbers that do this, and don't forget the numbers you multiplied. Sometimes those are the numbers that actually work. It doesn't happen a lot, but sometimes it does. So don't forget the numbers you multiplied here. 4 and negative 15 don't add to 17, so it doesn't work in this case. Now, there's lots of pairs of numbers that multiply to negative 60. So here's 5 pairs, and of course, I could put the negative here instead. Okay, it wouldn't matter. The reason I put all the bigger numbers with positives because the sum is a positive. So that's why I wrote those. So that adds to 14, so not 17. That adds to 11. That doesn't work. But these pair here, that adds to 17. Okay, so that's the pair that works. That's our decomposing number. Rewrite this, decompose into 17 down to minus 3m plus 20m. So again, don't forget to write your common factor of 2 down. So when in the next step, again, write the 2 down. There's a common factor of just m here. So m comes out of this, leaving a 4m minus 3. And there's a common factor of 5 here. So we factor a 5 out of this, leaving 4m minus 3. And then, again, common factor of 2. And then we factor the 4m minus 3 out. And what's left for the other factor is the m plus 5. Last example down here, number 5, we're asked to factor 3t squared plus 12t plus 5. So we need two numbers that add to 12 and multiply to 15. Now the only pairs of numbers that multiply to 15 are 3 and 5 and 1 and 15. Okay, everything's positive, so I don't have to worry about any negatives. And 3 and 5 don't add to 12, that adds to 8 instead. 1 and 15 adds to 16, so it doesn't add to 12. So that's why this trinomial wouldn't factor. So you would just say it can't factor, okay, because there's no pairs of integers that add to 12 and multiply to 15. And that's the end of the tutorial.